So we're going to look at this equation and we're going to look at it in two different ways. One of them, we're going to look at it in a visual way, try to represent it using counters. And the other one, we're going to use the standard algorithm. So when I'm looking at this, what this is saying is M is this container, right? I often talk about the variable as if it was a box or some sort of container. This over 2 is saying that I'm taking all of M and I'm splitting it into two equal parts, right? So the whole thing was M. I'm splitting it into two equal parts. So this part is just M over 2. And according to our equation, right now it's saying that m over 2, that portion of my box has 5 positive counters, right? 1, 2, 3, 4, and 5. When we're looking for m, we're looking for what's the quantity that we would have then in the entire box. Well, if half of it has 5 pieces, the other half needs to be just as big, have exactly the same amount. So this side would also have 5 pieces, right? Meaning the entire box would then have 10 pieces altogether. So we know that M, this box, has a total of positive 10 counters. If we look at it using the standard algorithm, we say that a fraction represents division. And in order for me to isolate this variable, right, or leave this m by itself, I need to move this divided by 2 portion of the equation. So then in order for me to get rid of this 2, I need an inverse operation. Right now, this is representing division, and the inverse operation to division is multiplication. And our properties of equality say that whatever we do to one side, we must do to the other. So if I'm multiplying this side by 2, I must be multiplying this side by 2. Right? When I multiply this by 2, I get 2 over 2, which is equal to 1. And 1m is just m. And 5 times 2 is 10. Well, in this case, we can see it here. We ended up doubling this in order for me to be able to get the entire m. That's why we end up multiplying by 2, because we actually have 2 of these.